In this video, I am going to explain how we integrate a rational function using partial fraction method. Let me explain what is a rational function first. Suppose I have two polynomials p of x and q of x in the form p of x over q of x and q of x not equal to 0, then we say that this is a rational function. There are two kinds of rational functions are available. One is called proper rational function. The other one is called improper rational function. If the degree of p of x is less than the degree of q of x, then we say the given rational function is a proper rational function. Otherwise, we call it as an improper rational function. In this presentation, I will focus only and I will talk about only proper function. We will discuss improper function in a later video. Okay. It also notes that before using the method partial fraction, we need to factor the denominator q of x into either a linear factors or quadratic factors if needed. Sometimes the given problem itself, it is in the factor form. If it is not in the factor form, then we have to change the denominator into either linear or quadratic factors. Okay. Before we go to the problems, let me explain the different kinds of problems are available in this session. The first one is called distinct linear factors. So what is distinct linear factors? If you see the denominator here, I have x minus 3, x plus 5 and x plus 6. That means I have three types of distinct linear factors 1, 2, 3. So to solve this kind of problem, I have to introduce three values a over the first factor x minus 3 plus b over the second factor x plus 5 plus c over the third factor x plus 6. Sometimes we have repeated linear factors. Say for example, I have some function in the numerator, let us say f of x, over we have a repeated linear factors x minus 1 the whole power 2. Then I can say a divided by x minus 1 to the power 1. We have to begin with the least power of the given factor, b over x minus 1 the whole power 2. Sometimes we have a combination of linear factor and repeated factors. Then how do I apply partial fraction? Say for example, if I have f of x over x plus 4 divided by x plus 2 the whole square. Then for the first linear factor x plus 4, let me write a over x plus 4. Then for the second linear repeated factors x plus 2 the whole square, I can write b over x plus 2 power 1 plus c over x plus 2 the whole power 2. Sometimes we have the third option. That means we have distinct quadratic factors. In lower classes, we have learned that a quadratic equation is in the form ax power 2 plus bx plus c equal to 0. So when you compare this quadratic equation into this one, we will easily identify that there is no x term involving. So in this kind of problems, how we write the partial fractions? We can write a multiply x plus b over x power 2 plus 4 and plus c divided by x plus 1. That is, we need to multiply x either with a, that is ax plus b, or you can also write a plus bx. That means we need to write 1x either with a or with b. Usually we prefer the first one, a multiply x plus b. For example, suppose I have f of x over x minus 2 divided f of x over x minus 2 times x power 2 plus 3. Then how I write the partial fraction? For the first linear factors, let me introduce a. So we have a over x plus 2. If you see the second factor, it is a quadratic factor, right? But there is no x term involving. So what I do? I have to multiply x with b and c. because we already introduced a. So you need to write b multiply x plus c over x to the power 2 plus 3. Let us begin with some examples. Example number 1. Evaluate integral 5x minus 3 over x power 2 minus 2x minus 3 times dx using partial fraction method. So first, before solving the problem, you need to check whether the given problem is a proper fraction or improper fraction. This is a proper fraction. How it is a proper fraction? Because the degree of the numerator is 1. The degree of the denominator is 2. So it is a proper fraction. Then step number 2, you have to split the denominator function into linear factors or quadratic factors. So in the denominator, I have x power 2 minus 2x minus 3. If I factor this, I will get x plus 1 and x minus 3. So clearly these two are non-repeated linear factors. So we have to apply the rule of partial fraction for non-repeated linear factors. So we just write the problem 5x minus 3 over x plus 1 times x minus 3. Since I have two linear factors x plus 1 and x minus 3, let me introduce two values a and b. So how I write the partial fraction? A over x plus 1 plus b over x minus 3. Let us name it as this as my equation number 1. Okay, now what I do, I have to multiply this equation number 1 both sides, that is left hand side and right hand side, by these two linear factors x plus 1 times x minus 3. That means the left hand side times multiply x plus 1 times x minus 3, and then right hand side we have two terms. So we multiply first term by x plus 1 times x minus 3, second term by x plus 1 and x minus 3. So it is easily observed that this x plus 1 x minus 3, this x plus 1 and x minus 3 both cancel. If I come to right hand side, I can cancel x plus 1 for the first term, and we can cancel x minus 3 for the second one. So let me write remaining values. So this we have 5x minus 3 is equal to a times x minus 3 plus b times x plus 1. Now what is my next step? In my next step, I need to find the value of a and b. To find the value of a and b, you have to look for the linear factors. So here I have minus 3, and here in the second factor I have plus 1. So what I do, I have to take the opposite values. So let me take x minus 3, and I have to substitute x minus 3 in this equation. If I substitute x equal to 3, I will get b equal to 3. Same way, if I apply x equal to minus 1 and simplify, I will get a equal to 2. In the next step, I have to substitute both a values and b values in equation number 1. So I will get this form. The question is, I have to integrate this function. I have to integrate this function. So what I do, let me integrate both sides of this equation. Let me say equation number 2. So I have to integrate equation number 2 both sides with respect to x. So we have integral 2 times x plus 1 into dx plus integral 3 over x minus 3 into dx. So we have taken 2 outside from the first integration, and we have taken 3 outside from the second integration. So we have left with integral 1 over x plus 1. In the second term, we have left with 1 over x minus 3. It is easily observed that the integration of 1 over x plus 1 is ln x plus 1, and 1 over x minus 3 is ln absolute value of x minus 3. So we have declared this is our final answer. 2 times ln the absolute value of x plus 1 plus 3 times ln the absolute value of x minus 3 plus c. Thank you.